All right, everybody. So 8.5, like I said, deals with rational functions. And this means we're dealing with fractions. So anytime you see that word rational, that's what they're talking about, fractional, okay? So y'all really, it starts out doing domain problems, and we did domain problems way back in chapter 2. Um, but now the difference is we're going to use interval notation instead of set builder notation. So interval notation, I want to go over that real quick. We sort of did interval notation when we were doing the increasing and decreasing. Remember, it had the curvy parentheses. Um, so this is sort of using that. But when we're dealing with fractions and there's numbers we got to exclude from the domain because it makes it undefined, there's a new way we're going to kick out those numbers, okay? So let's start off by looking at interval notation. So in interval notation, we use negative infinity to represent all real numbers. So before we actually had to write that out, remember, x is a real number such that x was not equal to 5 and all that fun stuff. Well, we're using interval notation. It's sort of like shorthand. So from negative infinity to infinity, that's what we use to represent all real numbers. Now, to exclude a number from the domain, we use the union symbol. And y'all, the union symbol looks like a U, okay? So in math, this means and. Okay? So to exclude a number A, remember, A can be any number. So to exclude a number A, we would write, all right, so it's going to start at negative infinity, and then we go up to A. Now, since I'm using these curvy parentheses around the number, when you use curvy parentheses around a number, that means it excludes that number. And then you use the union, and then it starts to the right side of the number and goes towards infinity. So since we got curvy parentheses around the A, it actually excludes that number. So we can go from negative infinity on the left side up until we get to A, but not including A. So we're going to exclude it by using the union here. And then from this side, it takes off from the right side of the number and goes towards infinity. So this union move right here is how I'm going to exclude my numbers, okay? So y'all, does that make sense? Uh-huh. So let me do some examples, and these examples want us to so watch these examples, and I think this will explain it for you. So we're going to determine the domain of the function. So let me do my first one here real quick. All right, y'all. So number one, I'm going to have f of x equals x squared over 6 minus x. Now, we still find the domain the same way. We worried about the bottom only. The denominator is all we care about. And it cannot equal zero, remember? So what I did on these, I set the bottom actually equal to zero and solved it for the variable. Once I solved it for the variable, I knew what numbers to exclude, okay? So like for this one, to solve it, I would subtract 6 first. So that cancels. I get a negative x equals negative 6. And then to make my x positive, I would divide both sides by the negative 1 in front of it. So this gives me a positive x equals a positive 6. So 6, if I put a 6 in, 6 minus 6 makes that 0, which makes it undefined. So we're only going to kick out 6 from my domain. So my domain will go from negative infinity up to 6, but not including 6. And then it'll start from the right side of the 6, not including 6, because of the curvy parentheses. And then it'll go towards positive infinity. Remember when we were doing the less than or equals, when greater than or equals with the radical stuff, when I included the number, I used brackets, okay? So brackets include the numbers, parentheses exclude them. And y'all, you just got to remember, infinity always has curves, parentheses, because there's no stopping point. It just keeps going and going and going, okay? All right, so let's look at one more of these. So this one has f of x equals 3 over x squared plus 2x minus 24. So we got a quadratic equation here. So since I got an exponent 2 on this one as my highest exponent, that tells me I need to exclude 2 numbers from this domain. See, this one just had 1x, so you only got 1 number to exclude. But y'all, x squareds give me 2 numbers to exclude. So once again, I'm going to set x squared plus 2x minus 24 equal to 0. Now, I'm going to solve mine by factoring, but if you want to, you can use the quadratic formula, or you could even graph it to see what the solutions were. So I'll factor it, but y'all let me show you what I'm talking about. If you're not very good at factoring, you can still get the solutions by graphing it. So let me show you. So let me go to y equals. And let me put that in. X squared plus 2x minus 24. Remember, the solutions are equal to the x-intercepts of your graph, right? So when I hit graph, I can see where that's crossing on the left side and the right side. So let's see, that looks like negative 1, 2, 3, 4, 5. That looks like negative 6 on the left side. That's going to be one solution. And on the right side, 1, 2, 3, 4. And watch this, if I look at the table, and let me go up to, there's 4 zeros, so that's definitely one solution. And then let me go down where I had negative 6. So at negative 6, it gives me a y value of 0. So that means negative 6 and 4 are the solutions to this equation, okay? Now, I'll solve it by factoring. So x squared is an x and an x. Remember, this last number's negative. Anytime that last number's negative here, that means you got unlike signs. One will be positive, one will be negative. Now, I'm looking for factors of 24 that'll subtract and give me 2. That's going to be 6 and 4. At this point, remember, the larger factor always has the same sign as the middle number, and then the 4 will be negative. So you just got to find 2 numbers that multiply to get 24, but they add to get a positive 2. And since the last number was negative here, we knew they had to be unlike signs. All right, now the rest of this, set both of them equal to 0. So the first one, I would subtract 6. And y'all, there's our -6 we had. And then over here, we would add 4 and get a +4. And there is our second answer we had on the graph, +4. Now you got to go in order, left to right. So we start at -infinity. The first number you come to going left to right is -6. So we're going to union around that -6. From -6, we're heading to the right until we get to the 4. Well, we got a union around that 4. And then since 4 is the only other number I'm kicking out, my domain heads off towards +infinity. So this tells me that -6 and 4 make that undefined, okay? All right, y'all. So that's what you got to know about interval notation. Um, and that's just another way to write domains, okay? All right, so now we're going to learn about graphing these type of functions. So what we're going to learn about next are what we call asymptotes. So let me start out with and so these are going to be some definitions. So this one is a vertical asymptote. Okay, so y'all need to write this still. And then really this is the main thing we'll be doing in this section is learning about asymptotes and then looking at sort of how to graph these rational functions, okay? All right, so in vertical asymptote, essentially this is an imaginary vertical line. So it's imaginary vertical line that occurs where a graph is undefined. The graph cannot cross over the vertical asymptote. That's because it's undefined there. And since it's undefined there, these graphs cannot go over that, okay? All right, y'all, let me let a few in real quick. Okay, so the graphs cannot cross over it, and they come in the form of an equation. X equals some number. Okay? Because remember, when we were graphing, X's were vertical lines when we graphed them, okay? So that's why these vertical asymptotes come in this form. Okay? So what that would mean, say I had me a graph here. So say I had a graph like this. F of X equaled 1 over X. Well, we could tell by this one, if we set the bottom equal to 0, the only number that cannot be put into this fraction is a 0. So what that means, y'all, is at the X value of 0, which is the Y-axis, right? There would be like an imaginary vertical line right here. Now, this was my basic graph. So I'm not going to go through the whole table. I'm just going to show you what it cannot cross this line. So what happens on this graph, it comes from the left side, it gets near that, and then it just goes straight down. It heads towards negative infinity in the y direction, but it does not cross over that graph, okay? Now on this side, this graph, remember the basic graph? It started up here from positive infinity. It came down and then it sort of shot along. It does not cross over this imaginary dotted line, okay? Because the graph is undefined at that section, so there's no numbers we could put there that keep it from being undefined. So that's what these are called. When you see graphs doing that, getting near a number, but they don't cross over it, that's because they're undefined at that section, okay? So that's your vertical asymptotes. They occur where your graphs are undefined. Now we got a second one we're going to look at. Horizontal asymptote. And guess what? It's also an imaginary line, but it's a horizontal one, okay? So this is an imaginary horizontal line that the graph approaches as the x values head off toward negative infinity and positive infinity. Sort of like what I got here. This line, if I kept going down and down and down, is trying to get to the x-axis. So on that one, my horizontal asymptote would be the x-axis on this one. Because as you go out towards these infinities, these y values are getting closer and closer to zero, but y'all, they never get to zero. They just keep getting closer and closer and closer. But they never will reach that horizontal asymptote, okay? Now, these come in the form of, now since they're horizontal lines, they're going to be y equals some number. So the vertical asymptotes are x's, horizontal asymptotes are the y values, okay? So now here's the thing on the horizontal asymptotes. There's three cases for a horizontal asymptote. Now we're going to look at the three cases because in one of the cases, you don't get a horizontal asymptote because the graphs are headed towards infinity. On one case, the horizontal asymptote is going to equal the x-axis where y equals zero. And then the third case, you look at the numbers in front of the function to get the asymptote. So there's three cases, and each case depends on the degree. We look at the degree of the numerator and we look at the degree of the denominator. Now remember, the degree of a polynomial is its highest exponent. Okay? So when I'm talking about degrees, I'm talking about the highest exponents. So the first case, if the degree on top is greater than the degree on the bottom, then, so if the top exponent is bigger than the exponent on the bottom, then there is no horizontal asymptote. So I'm going to use HA to represent my horizontal asymptotes, okay? So if the top is bigger than the bottom, that means the top's growing a lot faster than the bottom. So the graph is headed towards infinity and there's no horizontal asymptote. Second case, if the degree of the bottom is greater than the degree on top. So if I got a bigger exponent in that denominator, then the horizontal asymptote is going to be y equals 0. So the bottom is going to grow a lot faster than the top because it's got bigger exponents. So that means the overall fraction as you go towards infinity is going to get closer and closer and closer to 0. You'll get numbers like 0.01, 0.001, 0.0001. They're getting smaller and smaller, but it never gets to the 0, okay? All right, y'all, then we got this third case. So we got the top grader, the bottom grader. What if they're equal? If the degree on top equals the degree on bottom, then y will equal a over b, where a is lead coefficient on top. Now remember, coefficients are the numbers in front of those variables. So a is the lead coefficient on top, and b is the lead coefficient on the bottom. Now just remember one thing. If, say, your top had an x squared and the bottom had a 3x squared for their biggest exponents, since there's not a number in front of the x squared on top, you would treat it like a 1, remember? So when you don't have a number there, we're going to still treat it like a 1. Okay? So let me go to MathLab and show you what kind of examples these are going to be. So y'all, I'm going to share that real quick with you. Hey, y'all, so let me write this down real quick. They're giving us r of x equals 7 over x squared minus 36. Now it says they want me to find all the asymptotes and then graph it. So I'm just going to graph them on my calculator when it gets to that point and pick one of the pictures. Because all you got to do is pick pictures on this section, okay? So let's go find these asymptotes. Alrighty, so to find my vertical asymptote, I'm going to set the bottom equal to 0. Now this one's quadratic, but remember, it's just got the x squared term and a number. So to solve this one, I'm actually going to do the square root to it, okay? So I'm going to solve it by adding 36 and doing square roots. I think that's really the easiest way when you don't have that x term in the middle on these, okay? All right, so now we do square roots. So square root of x squared is x. Square root of 36 is a plus or minus 6. Remember, x squared, you got to get 2 answers. So my horizontal asymptote would be x equals 6, comma, x equals minus 6. Now remember, you got to type them in the form of an equation in MATLAB. So this is what it wants for your vertical asymptotes. So then my horizontal asymptote. So for the horizontal asymptotes, I got to decide if it's got a higher degree on top or does it got a higher degree on bottom. So y'all, what do y'all think? Does this function got a higher degree on top or a higher degree on the bottom? Now just remember, I'm looking at exponents. So since you don't even have a variable up, so let me show y'all this one. This is sort of tricky. So since there's not a variable on top, so no variable on top, that means the degree on top is 0. And then the degree on bottom, the degree on bottom equals a 2. Okay, so no variable, 0 would be your degree. And then this one did have a variable, so 2 was the degree on the bottom. So that means the bottom was greater than the top. So what did we say if the bottom was greater than the top? We said that that would be y equals 0. All right, so I got my vertical asymptote is at -6 and 6. My horizontal asymptote would be at 0. So let's go put that in, and then we're going to pick a graph, and I'll show you how to graph them, okay? All right, y'all, so this is going to be x equals 6, comma, x equals -6. Okay, so type the equation, check that answer. On oblique, anytime you see this oblique, you're going to put no. There is no oblique asymptote. We don't cover those in our class. So anytime you see that, just put no for that. And then here comes my horizontal asymptote. So remember, we said since the bottom was greater than the top, that was going to be y equals 0. So remember, got to be an equation on that one also. And then check your answer. Now look at these 4 graphs. A, B, C, and D. Let's go graph it and see which one we get. So I'm going to go to my calculator. Go to y equals and clear that. All right, so I'm going to make it look like a fraction. Alpha y equals and enter. You definitely want to make these look like fractions, okay? So you'll have a 7 on top. And then on bottom I had an x squared minus 36. Now we'll say this, y'all. If you don't do this fraction notation like I did, you have to put parentheses around the top and bottom if you're using the divide for it, okay? So like if you did 7 divided by x squared minus 36, you would have to put them in parentheses so that the calculator would know the top from the bottom, okay? All righty, so let's look at the graph. So see over here at -6, you can see there's an imaginary vertical line that the graph don't cross. Over here at +6, there's an imaginary vertical line the graph can't cross. And then you can see on the left and right side, as you go towards those infinities, it's trying to get closer and closer to 0. And y'all, let me show you the table. By hitting second graph, you get an error at -6. That's your first vertical asymptote. If I go down to +6, I get an error. That's my second one. Now watch as I go bigger and bigger on the x's. 7/13, 1/4. those fractions are getting smaller and smaller and smaller and smaller. 1 over 52, 1 over 64, 1 over 99. As I head towards infinity, them x's are getting smaller and smaller as I go, okay? All right, y'all, let me look at that graph again. So it looks like it's got an upside down U shape in the middle. So let's go to MATLAB. And y'all, looks like I'm going with D on that one. So then you would check that answer and be done, okay? All righty, so that's on graphing it, okay? So now let's look at some examples. The next few examples are going to go through vertical asymptotes, and then there'll be some examples doing horizontal asymptotes. And these examples are only asking for the asymptotes, okay? So we don't have to graph and do all that stuff. All right, so y'all, these are going to say find the vertical asymptotes of the function. All right, also for this one, I'm going to do f of x equals x minus 4 over x squared plus 3x. So vertical asymptotes, I'm only looking at the bottom. The bottom cannot equal 0. So what I'm going to do is set x squared plus 3x equal to 0. So if I solve this, it'll give me the two numbers that are going to become my asymptotes, okay? Now, y'all, this one, you got an x squared and you got an x. Notice up here, I had an x squared and a number. When you got an x squared and an x, the easiest way to solve this is factoring out the greatest common factor. So x squared and x, they both have an x. So you would factor that out. And then in parentheses, that leaves an x plus 3. All this equal to 0. Sort of like I did the other day when I was factoring those 4-term polynomials, okay? So x squared divided by x left me an x. 3x divided by x left me a 3. Now, I would set both these equal to 0. So remember, the single variable always equals 0, okay? And then this one, x plus 3 equals 0, I would subtract 3 from both sides and get x is a negative 3. So in MATLAB, I'm putting x equals 0, comma, x equals negative 3. Those would be my two vertical asymptotes, okay? All right, y'all, this one. So let me pull some off of MATLAB real quick. Let me see what they got going on. All right, so look what they got. F of x equals negative 3 over x plus 2, x minus 4. So the thing on this one, it's already factored into parentheses. So what you would do, you would come down and set x plus 2, x minus 4 equal to 0. So since it's factored already equal to 0, I'll take each factor and set them equal to 0. So here I would what? Subtract 2. And y'all, we get x is a negative 2. This one, you're going to add 4 and get x is a positive 4. So two factors, two numbers you're excluding, okay? And you would do this. X equals -2, comma, x equals +4. So the trick on these is just figuring out how to get them solved, okay? And they're throwing different equations at you. X squared with the x terms here. X squared with the numbers here. Already factored here. And y'all, that's what they're doing. They're just going to keep changing the different ways we got to solve them, okay? So y'all, let's do one where you had to factor it then. So let me see. This one will be f of x equals x squared plus 2x minus 15 over x squared minus 4x minus 21. Alrighty, now I'm going to factor it, but remember, you can graph this in y equals and find those two x-intercepts and get the answers that way if you want to graph it, okay? Um, I like to factor to get y'all better at factoring. So set it equal to 0. Now remember, this is going to be in parentheses. X squared would be an x and an x. And remember, I said if this last number is negative, one factor will be positive, one factor will be negative. Now, give me factors of 21 that'll equal 4 if you subtract them. Because exactly, 7 and 3. Now remember, the larger number always has the same sign as the middle. And then the 3 would be your positive. And y'all, you check these. 3 and -7 equal -4. 3 times -7 equal -21. Okay? So we're good. Now finish it off by setting both them equal to 0. So y'all, let's see here. We subtract 3. And I get a -3. Here, I would add 7. And get x is a +7. So if you was to graph this x squared minus 4x minus 21 in your y equals, it's crossing the x-axis at -3 and +7, okay? All right, so what's MATLAB want? It wants those two equations and separated by a comma. All right, so y'all, there it did. It went through a few horizontal asymptotes. Because what's going to happen at the end of the chapter, we're going to graph again, but we're going to sort of learn more things to graph with, okay? And I'll show you what I'm talking about when we hit it. Um, so these examples, there's 3 examples we're about to do, and they want us to determine the horizontal asymptotes of the function. So since it's horizontal asymptotes, I'm now looking at the degree of the top and the degree of the bottom. So my first one has f of x equals 4x squared plus 5 over 5x squared minus 3. All right, y'all, you had 3 cases. You was higher on top on the degree, you were higher on the bottom on the degree, or they were equal. So what case does this one have? Exactly, they're equal. So the top degree equals the bottom degree. So that means our answer is going to be y equals, and that was a over b. Well, a over b are the numbers in front of the variables. So a on top is 4, and then on bottom, b would be the 5. And y'all, that is what MATLAB wants for my horizontal asymptote. When they're equal, it's the numbers in front. So that means as these x's head off towards infinity, my graph is trying to get to 4/5, which is sort of close to 1. So it's trying to get closer and closer to that 4/5, okay? All right, y'all, next one. How about f of x equals x squared minus 8 over 3x to the fourth plus 2. All right, where are we bigger, top or bottom, or equal? So we're bottom. So remember, the bottom degree is greater than the top degree. So what did we say if the bottom degree was bigger than the top degree? Do I have an asymptote? And if so, what is it? Or did I not have an asymptote? Y equals 0. Perfect. When the bottom grows faster than the top, it's going to head off towards 0. So that one would be y equals 0. So it looks like these examples, they're giving me one of each, ain't they? And y'all look at this one. F of x equals x cubed minus 5x squared plus a x minus a 3. All of that's over x squared minus 18. So top, bottom equal. So top is definitely bigger than the bottom. So if the top had a higher degree than the bottom, what did we say about that one? And y'all, let's see, there's only one more case, right? Because this one was equal to the A over B. This one was equal to the 0. So the only other case when that top was bigger than the bottom, when y'all got there, exactly, there is no horizontal asymptote. So that means these graphs are trying to go towards infinity, okay? All right, y'all, so let's start. Let me show you how to graph these things. Now, I usually answer the questions and then I use my calculator to graph them. So let's go to MATLAB and see what they want us to do. And y'all, let me think. Let me see where I'm at on these. All right, that was horizontal. All righty. So let me write this one down. This is f of x equals 3x plus 2 over x. Now look what they want. They want the domain, any asymptotes, x and y intercepts, okay? So they want domain, asymptotes, and then what I say, x and y intercepts. All right, so we'll go find all that stuff and then we'll come in here and pick our answers, okay? All right, y'all, so let me get this set back up here. All right, so I'm going to find domain, asymptotes, x and y intercepts. And really, when you find a domain, the vertical asymptotes are going to be the same because you find the vertical asymptote the same way you find the domain. So that's what's nice on that, okay? Now, they want me to put the domain in the interval notation. So, y'all, to find the domain, I set that bottom equal to 0. Well, we cannot do nothing to that. So the only number that x cannot be is a 0. So in interval notation, I would go from negative infinity up to 0 and union around that 0. Because remember, I'm kicking out 0 by the union. And then it goes towards positive infinity. So the domain would be negative infinity to 0, union around 0, and then you're going towards positive infinity. Now, that was the domain. The vertical asymptote, well, y'all, we set the bottom equal to 0 and solved it right there. So a Monty perfect. Vertical asymptote is going to be x equals 0. So let me ask you about this. What about a horizontal asymptote? Are you bigger on top or bottom? Well, y'all, you got an x on top, which has an exponent of 1. You got an x on bottom. Oh, let me ask y'all, where y'all getting, actually, these ones are equal. Remember, because this has an exponent of a 1, the bottom has an exponent of 1. Remember, I'm looking at the biggest exponents. Now, Amani, although they're equal, it is y equals 3, okay? Because remember, the top equals the bottom. So it was y equals a over b, which is 3 over 1. So that reduces to a y equals 3. So MATLAB's going to want that as a, if you got a 3 over 1, make that a 3, okay? So this one is equal, y'all. Okay. Let me show you how to find x-intercepts. For x-intercepts, we set the numerator equal to 0. So my numerator is 3x plus 2. So I'm going to set 3x plus 2 equal to 0. And then I'm going to solve that. Well, y'all, to solve this, we would subtract 2. And then divide by 3. So that x equals a negative 2/3. This is my x-intercept. Remember, x-intercepts have to be written as an ordered pair. So the x value is negative 2/3. The y value would be 0. All right, then they want my y-intercept. So when you want y-intercepts, you want to find f of 0. Right? Y-intercepts happen where the x values are 0, okay? So we're finding f of 0. So f of 0, so here we go. F of 0 equals 3 times 0 plus 2 over 0. Oh, can we even work that? Oh, Amani, you're doing good. You can't do this. You can't have a y-intercept because this is undefined. This is undefined. Because way back up here, remember, we said x equals 0 is a vertical asymptote. It's undefined at that point. So you cannot work this as undefined. So that means that there is no y-intercept. Okay, y'all? If it makes it undefined, you can't have a y-intercept because that graph cannot cross over that. So Amani, good job. That is excellent. So let's go sort of answer Math Lab, I guess. All right, so our domain we said was what, kicking out 0 only. So y'all, that was A. Um, Now it wants to know the x-intercept. Well, we did have an x-intercept, so that was a parentheses. Oh, when I get a negative 2/3, so I'm going to use the fraction, do a -2, and then arrow down and put in my 3. Arrow right, comma, 0, close parentheses. All right, so that's -2/3, 0. So check that. The y-intercept, remember, Monty, y'all said there was no y-intercept, so we would choose B, no y-intercept. Then it wants me to choose the right graph. All right, so look at these graphs. Let's go to y equals on our calculator, and we're going to graph that real quick. So y'all let me clear that off. All right, I'm going to hit alpha y equals and enter. So y'all on top was a 3x plus 2, and on bottom was an x. So really, all we want to look at is the graph. All right, so it's above the y-axis, it's above the x-axis, and it sort of goes down on the left side, and then the right side is sort of downhill. And apparently, that's headed towards 3, right? If you go 1, 2, 3 up on the y-axis, that's what them lines are trying to get to going left and right. All right, y'all, so we would pick that picture. So, I'm thinking C here, right? Let me make that bigger. I think that's C, right? See, the left side is sort of, it's almost at the 3. That's that dotted line is at 3 right there. And it goes down and then the right side. Yeah, I think that's going to be C on that one. And then you're going to check your answer. All right, y'all. So let me write this one down. So we'll do one more of these and then we'll go to the next section. So I got an x squared plus an x minus 2 over x squared plus 3x plus 2. All righty, so same thing, right? Domain, x and y intercepts, and then graph it. So we didn't physically have to find these asymptotes, I guess. They just want us to know them so that when we look at the graphs, okay? All righty. So the domain I'm going to do by setting that bottom equal to 0. And remember, when I find a domain, it's basically going to give me the vertical asymptotes because the vertical asymptotes cannot occur where this is undefined anyway, okay? So I'm going to factor this one, or you can graph this and look for the x-intercepts. All right, y'all, when the last number is positive like that, when the last number is positive, both of these factors will have the same sign as the middle. So these will both be positive. Oh, and I've only got one guess for the factors of a 2. The factors of 2 are going to be 2 and 1. So if you got a prime number here, that can only be the factors, okay? All right, y'all finish it off by setting those equal to 0. Subtract 2 from our first equation. Subtract 1 from your second equation. Oh, now remember, these got to be in order. So the negative 2 will come before the negative 1. So negative infinity to negative 2. Union, y'all, negative 2 to the negative 1. Union around that negative 1. So I'm kicking out negative 2 here, kicking out negative 1 here, and then it heads towards positive infinity. Now, the vertical asymptotes would be the x equals negative 2, x equals negative 1. Okay, that's where those imaginary lines are going to be. So technically, they're on the left side of the. So y'all, you can almost sort of graph these by hand in a way. Here's negative 1 and negative 2 on the x-axis. So we know right there, we're going to have 2 vertical asymptotes on that one side right there. Okay. All right, what was next? X-intercepts and then y-intercepts. Now, I do know that the top is a degree 2, bottom is a degree 2. So they're going to approach 1 over 1, which is 1. So up here at 1 on the y-axis, eventually they're going to try to get to that 1 as these x's go to the left and right, okay? So let's see the x-intercept. X-intercept will tell me where it's crossing over the x-axis. And remember, to find the x-intercept, I set the top equal to 0. All right, y'all, so I'm going to solve this one by factoring x into x. That last one's negative, so one's positive, one's negative. The only factors of 2 are 2 and 1. So the larger factor will be positive like the middle, and then the 1 will be negative. All right, so I'm setting both of them equal to 0. So subtract 2. I get x is a negative 2. And here I'm going to add 1 and get x is a positive 1. So check this out. This thing was undefined right here at negative 2. So I cannot have an x-intercept there. It's undefined at negative 2. Okay? Now, what happens when this happens, your x-intercept occurs where it's undefined. Instead of a vertical asymptote there, what's going to happen is it's going to make a hole. It makes a hole in the graph if this x-intercept matches that undefined number there, okay? So technically, it cannot have this x-intercept. It's undefined there. So that means that positive 1 right here, so if this was 1 on the x-axis, that's where that thing is crossing the x-axis at, okay? So let's find the y-intercept. Y-intercept is where it's going to cross the y-axis at. Because usually once I know what this is doing, then I know what my graph will look like. And if you remember, to find the y-intercept, I found f of 0. So f of 0 equals 0 squared plus 0 minus 2 on top over 0 squared plus 3 times 0 plus 2 on the bottom. Well, y'all look at that. 0 squared is 0. Plus 0 is 0. Minus 2 gives me a minus 2 on top. 0 squared plus 3 times 0 is 0. That's a big 0. Plus 2. All right, y'all, that -2/1 will turn into a -1. Now, remember, MATLAB is going to ask for the x-intercept as a point, so that one will be 1, 0. The y-intercept is going to be 0, -1. So the x-intercept has a 0 for the y. The y-intercept has a 0 for the x. So y'all, that means right here at -1 on the y-axis is where that's crossing. So this one has no choice but to come up like this. It's going to get right here. And then eventually it's going to try to get to that vertical asymptote there. So watch what happens when I graph it. And then, y'all, this side is going to make a hole in the graph. So let me show you. Let's go to our calculator. I'm going to go to y equals and clear that out. Alpha y equals and enter to get my fraction. So we had an x squared plus x minus 2 on top. On bottom, I had an x squared plus 3x plus 2. Okay, so I just want to look at the graph real quick. And y'all, there it is. There's that side coming across. -1 right there on the y-axis, and then it crosses at 1 on the x-axis, and it's just trying to head out. Now, over here at this -2, you can't see the hole in the graph, but watch out when I go to the table. When I go to second graph for the table, look, -1, you get that error. -2, you get an error. Okay, you don't see an asymptote there because it canceled out with that x-intercept and made a hole in the graph. So y'all, what actually is happening, so you can't see the hole, but remember this side came down, and when it's crossing right here, it would make a hole, and then it would go like that. Um, but we don't have to worry about that a lot. You're just going to graph it and get one of them pictures. Just remember this. When you're kicking out a number from the domain, you cannot have an x-intercept at that number, okay? Because it's undefined. All righty, y'all. So we're going to take a break. So let me quit sharing this and let me put us on pause. All right, y'all. Polynomial inequalities. Okay, so now we're going to be putting these answers in interval notation. Now remember, inequalities are greater than, less than, greater than equals, less than and equals. So the trick is in interval notation, if you have equals, so if we have greater than or equals or less than and equals, we're going to use brackets around the numbers. Otherwise, if we have just greater than or less than, if it does not have equals, that's when we're going to use our parentheses around the numbers. And just remember, negative infinity and positive infinity always use parentheses around them, okay? All righty. So these inequalities can have more than one answer, just like when we were graphing the inequalities and we were doing all that shading. Okay? So let me write the steps I use when I'm solving these. All right, first thing, you're going to have a polynomial. We're going to set the polynomial equal to 0. And solve. All righty. Now we're doing quadratic inequalities. So that means we're going to get two solutions on these, okay? So what I do at that point, I'm going to create a number line. Using the two solutions. Okay, so doing that, a number line, and the only places I really mark are the two solutions. So number line with my two solutions, okay? Then I find a test point. Because what you got to do is you got to test it and see what place we're going to shade. Okay, so I'm going to use a test point to determine if a section is true or false. And I check that by plugging it back into the original polynomial, okay? So I'm going to check and see if a section is true or false. If it's true, shade that section. Okay? Now watch. There's two things that can happen when you're shading. So let me draw my A and B again. All right, so these are either going to be true in the middle. If it's true in the middle, that's the only section that we're going to get shaded, okay? Or you can have this case happen. It's false in the middle, then that means it's going to be true on the ends. When we shade, it's either going to be the middle or the two outer sections, okay? You never shade a middle and an end. If you shade the middle, then that's the only thing that's going to be true, okay? These are either true or true on the ends, okay? And y'all, let me show you what happens here. So, let me just show you what this is representing. So I got a quadratic equation. So say this one's A and B. So to make this one shade in the middle right here, my function would have to be greater than 0. Because remember, 0 is the x-axis. Whoops, I mean, for this one to be true, it had to be less than 0, right? Because here's 0. So this part of the graph is below the x-axis. So that's the only part that's less than 0. Now, for this to happen, these two sections right here are greater than 0 because they're above the x-axis. Okay? So that's what you got happening. If it's greater than, these two sections are represented by this. If it was less than here, it's represented by this. It's under the x-axis between A and B, okay? So that's what's happening here. All righty. So now, once I know where I'm shading my number line, I'm going to write the answer in interval notation. So if you have this happening, your interval is going to be like this. You're going to be from A to B. Now it could be brackets. Okay, it could be brackets if it has equals in it. Now for this interval will go from negative infinity to A, and then from B to positive infinity. And then you would have a unit in there. So see, it goes from negative infinity to A, it skips in between, and then from B to infinity. This is the two answers we'll get, okay? Unless star number one, if you get repeating solutions, so say I solved one of these and I got x equals 2 and x equals 2. It's the same answer repeating. If you get repeating solutions, then that means that is the only number excluded from the domain. Okay, so if I'm getting a repeating answer, then my domain will be negative infinity to A union A to positive infinity. I'm only kicking out that one answer, okay? Star number two. If it does not factor, so if you cannot factor it and solve it, then we get a no solution. Now, in MATLAB, a no solution is a zero with a line through it. You have to use this symbol, okay? You must use this symbol if it's a no solution. If you write no solution, it will mark that wrong, okay? Okay, so I will say this. Most of them are going to be factorable. You will have one where you have a repeating answer, and we will have one that'll be a no solution, okay? All right, y'all. So let me let y'all have a second to write that, and then we're going to start solving equations. Now, remember this. If you don't like factoring, graph it and see where those graphs are crossing the x-axis at. And then, like I said, the one that would be no solution, it won't even cross the x-axis. Okay? So no solutions won't even cross the x-axis. Um, if it's got one solution, when you graph it, the graph will come down and be tangent to it. Sort of like that stuff we did the other day when it was tangent or crossing over the x-axis. Okay? All right, y'all. So let's go start solving some equations. Okay? Are y'all ready? All right, y'all. So these are going to say solve the inequality. All right, y'all. So I got an x minus 3 times x plus 1 has to be less than 0. All right, so this one's already factored. Now, I set them equal to 0 just to solve them. But when I'm doing my intervals, remember, there's not an equals under this, so I will use curvy parentheses when I do my intervals, okay? So first let's solve it by setting x minus 3 equal to 0, x plus 1 equals 0. So, y'all, the first one you would add 3 and solve that one. The second one here you would subtract 1 and get x is a -1. So your number line right here, the only two numbers we're worried about. So let's see, -1 would go first, and then my 3 would be over here. Okay? Now, y'all, let me tell y'all what I usually test. The only number I usually test is 0. So I figure out where would 0 be at on this number line. Well, 0 is going to be in between -1 and 3, right? So I know 0 is going to be in between them, and that's the number I'm going to test. Because y'all, 0 is the easiest number to test, okay? So if I'm going to test 0, I'm going to put a 0 into both of these x's and see if this is true. So watch this. I got 0 minus 3 times 0 plus 1. That has to be less than 0. All right, y'all, so this gives me a -3 times 1 has to be less than 0. -3 times 1 is -3, less than 0. Is this true or false? If this is true, we're going to shade it right in between where the 0 was. If it's false, we're not going to shade it where the 0 was, and we're going to shade it on the edges. So the question is, in the real world, is -3 less than 0 true or false? So y'all, that is definitely true. So since that's true, what I would do is between my -1 and 3, where my 0 was, I'm going to shade this. Now remember, when we shaded the middle, our answer is only going to look like this. It's going to have the two numbers, and we're either going to have curves or brackets, okay? Well, y'all, we said here, we're less than, we don't have the brackets, so our final answer is going to be parentheses, -1, 2, +3, and then close parentheses. That is what MATLAB wants. This inequality is only true between -1 and 3, but it cannot equal -1 or 3. Okay? And that's why we got the curves. All righty, let's try another one. X squared minus 15x plus 44 greater than 0. So what they're going to do on these is they're going to do different types of equations that you got to solve. So I'm going to solve this by factoring and setting it equal to 0. Or you could graph that, remember. Graph it and find out where it crosses the x-axis. Oh, y'all, watch this. Remember, this last number's positive right here. Since the last number's positive, both of these factors will be negative like the middle. All right, y'all, so let me ask y'all this. Can y'all find me factors of 44 that'll add and equal 15? So you gotta multiply to get a 44, but those two numbers gotta add to equal 15. And y'all, if y'all remember, I told y'all a trick on the calculator how y'all could do that. Watch this. Let me go to y equals and clear everything out. Remember, if I want factors of a number like 44, on the calculator, I would do 44 divided by x. And then I'm going to go to the table. So let's go to the second graph to the table. So I don't want negative numbers on here. So 1 and 44, that don't work. 2 and 22, that don't work. Oh, y'all look at this. 4 and 11. 4 and 11 will add to get us a 15, okay? So I'm going to put in my 4 and my 11. All right, negative 4 times negative 11 equals positive 44. Negative 4 plus negative 11 equals negative 15. All right, y'all, so to finish it out, set both of those equal to 0. So I'm going to add 4 and get an x equals a positive 4. And then here I'm going to add 11 and get x equals a positive 11. So I know my two numbers now for my number line are going to be 4 here and 11 here. Now, I'm still going to test 0, but 0 ain't in the middle this time. 0 is going to be on this first section because 0 is less than 4. So I know 0 is over here somewhere. I'm going to test 0. If it's true, I'll shade this section and my last section. If it's false, then I'm only going to shade the middle. Okay? So it's either the first and the last, or it's the middle on these, okay? All right, let's put zeros in. 0 squared minus 15 times 0 plus 44 has to be greater than 0. Well, y'all look here. 0 squared is 0. 15 times 0 is 0. So I end up with 44 greater than 0. True or false? Judy, you got true, Jesselyn, true. So since that's true, here was 4, here was 11. Since that's true, I'm going to shade it where 0 was located. And since I shaded the first section, I automatically got to shade that last section. So that means these two parts of my parabola would be above the x-axis since they're greater. All right. Now, since I got two intervals, this answer will be from negative infinity to positive 4, parentheses, because there's no equals, and then union that one from positive 11 to positive infinity. We cannot include the 4 to 11 sections because that was false. Okay? So y'all, they're not too bad. The trick is getting them factored. Once you got them factored and you got your answers, it's figuring out where are they true at. So if I'd have picked any number in here like 5, 6, 7 and plugged them into that, it would have been false. Okay? All right, so y'all ready to move on? Let's move on to our number 3. And y'all, that's all they're going to do on these is hit me with different types of equations. So y'all watch this one. 3, I got it. X squared minus 4x minus 19 greater than or equal to an x minus 5. So look, they got a lot of junk over here. I need a 0 on this side. I need all this stuff put over here, and I want a 0 on this side. So I'm going to subtract the x from both sides, and I'm going to add a 5 to both sides. I need to move both of those over, okay? So bring down your x squared. Negative 4 and negative 1 give you negative 5x. Negative 19 plus 5 is a negative 14. And that's going to be greater than or equal to a 0. So look here, we're ready to factor now. And I'm going to set them equal to 0 just to get my two numbers. Now, I do know this one will use brackets, right? Because you got equals under this one. So when I do my numbers, they're going to have brackets this time, okay? All right, y'all, x squared is x and an x. The last number is negative. Since the last number is negative, you got unlike signs right here. So what do we need? We need factors of 14, y'all, that'll subtract and give me a 5. Um, so let's see, what do I multiply to get a 14 and subtract and give me a 5? 1 and 14 don't work. So 2 and what do you got? Just 2 and 7? Perfect. Remember, 7's bigger, so the bigger number is negative like the middle, and the smaller number is positive. All right, y'all, I'm just going to solve these and get my two answers. So it looks like I'm going to get a negative 2 and what, a positive 7. All righty, let me set up my number line. So I had what, a negative 2 and a positive 7. All right, I think it's starting to rain here, sort of crazy. Um, all righty, so I know zero's in between a negative 2 and 7. So I'm going to test 0 by putting a 0 into this one. Since this one's already solved, this is the one I'm going to use, okay? Now, you could use that first one, but it's a lot more stuff there. So I'm going to do 0 squared minus 5 times 0 minus 14 has to be greater than or equal to 0. All right, so let's see. That's 0. That's 0. So I end up with a negative 14 greater than or equal to 0. So y'all, true or false? Is negative 14 greater than 0? All right, so that is false. So remember, since it's false, I cannot shade it where the 0 was, and we're going to shade the outer edges. So here's negative 2 and 7. So I cannot shade there, so I am forced to shade my outer edges. Okay? Which means my interval will start at negative infinity. Remember, infinity always uses the curves. But y'all, when I go to negative 2 this time, we gotta use a bracket because of the equals. And then we'll union that from the next number 7. It's got a bracket, and then it heads off towards positive infinity. So equals means brackets around those numbers, okay? All righty, y'all. So let's see what they're doing next. So this one has x squared greater than 81. So x squared in a number, I'm going to leave them like that. And I'm going to set x squared equal to 81 and solve it. Because all I got to do to this is do a square root to both sides. So square root of x squared is x. And y'all remember, this is a plus or minus now. Anytime you're doing an equation and you're taking square roots, you gotta account for the positive and minus answers of both, okay? And then square root of 81 is 9. So this interval will be a -9 and a +9. And once again, I'm going to choose 0. 0 is right in the middle here. Okay? Now, y'all, you don't have to use a 0. I just think it's the easiest number for me to use. Y'all can pick a number here, -10, -11. You can pick a number here, 10, 11, 12. You can pick anything in between here. -1, +1. It don't matter, okay? All right, so let me see. 0 squared greater than 81. So that is 0 times 0 is 0. 0 greater than 81, true or false? So definitely false, Julie. Good job. So once again, since it's false, I'm not going to shade where the 0 is located. And I'm only going to shade on the outsides. Okay? So once again, this interval will look like this interval, except one thing. There is not an equals under this one. So I'm going to use curves around my numbers. So -infinity to -9, curvy parentheses, union, curvy parentheses, 9 to positive infinity. Okay, y'all, so I'll let y'all catch up on that. And I'll tell you the truth. Remember, if these x squareds are positive, when they're positive, you got minimums. So it looks like a U shape. And when they're greater than, that means the edges are going to be above the line. If this was a negative x squared, it would flip it over and be sort of reverse. Okay, so remember, these are the U-shaped graphs, so positive x squares make the U, negative x squares flipped over. Oh, yeah, so let's see what's next. Number 5. 16 minus x squared is less than or equal to 0. So now I got a negative x squared, so this graph would be flipped over, okay? Um, but I'm going to solve this by setting it equal to 0. Move the 16 over by subtracting 16. So y'all, those cancel. I get a negative x squared equals a -16. Y'all, I think I'm going to do one thing here. Let me leave this as less than or equal for y'all on this one to match that. Because I want y'all to see there's going to be something happen on this one. And if you don't pay attention, you'll get this wrong, okay? So I'm just going to keep it using those. Because guess what? I need to make the x squared positive by dividing by -1. So what's that mean? What's that mean since I'm dividing by -1? I got to flip the sign. Exactly. So if you physically don't see it happening, you might not realize that up here, but this is really greater than or equal. I got x squared greater than or equal to a positive 16, okay? At this point is where I would start using my equals. But I would use the inequality as long as this thing was a negative, okay? Because you got to flip that thing. All righty, so now I would square root both sides. Square root of x squared is x. That's going to equal a plus or minus square root of 16, which is a 4. So once you're getting the numbers, you can use the equals. But y'all, at this point, I would definitely keep the inequality until you got your x squared positive, okay? So this is where I'm going to test my 0 on this part right here. All right, so my two answers were -4, +4. That means zero's in the middle again. So I'm going to put a 0 in right here. So 0 squared greater than or equal to 16. True or false? All right, so 0 squared made that a 0. But y'all remember, um, any any positive number is going to be greater than 0. And this is saying 0 is greater than -16. Y'all, that right there is definitely false. 0 is not greater than 16. It is less than 16, okay? So since that's false, where 0 was located, I would shade the outsides. Okay? So let's see my interval. We'll have brackets because of the equals. Now, infinity, like we said, always has the curves. But at -4, you'll use a bracket, union, bracket from 4 to positive infinity. All right, y'all, just remember this on this number line. If you had a number line, you got 0 here, 1, 2, 3, 4, and over here's your negative numbers. Any number to the right of another number on the number line is greater than that number. So 16 would be way over here, 0 is here, so that's why 16 was greater. They get greater heading toward the right, okay? And numbers get less going to the left. Okay? All righty, let's see what 6 had. Oh, y'all, they got a 6x minus 9 minus x squared less than 0. So, y'all, let me tell you what I would do to this. First thing, I'm going to get them in order. So, it looks like this negative x squared needs to go to the front. So, I got a negative x squared plus my 6x minus my 9 less than 0. Now, I want to make this x squared positive, so I'm going to divide everybody by -1. And since I'm dividing everybody by -1, I'm going to flip that inequality from a less than to a greater than. Okay, so remember, I'm flipping that one just like I flipped that one up there a while ago, okay? So I get a positive x squared. That's going to make a negative 6x. Negative divided by negative makes that a positive 9 greater than 0. All right, so now we're going to set it equal to 0 and factor. X squared is x and x. The last number is positive, so both of these factors will be negative like the middle number. Alrighty, y'all. Can you find me factors of 9 that'll add and get me 6? So 3 and 3. Uh-oh. We said we had a little star a while ago. This is a repeating answer. So remember, when it's a repeating answer on my number line, you would solve this and find what number to put right here. So let's see. X minus 3, if I set that equal to 0, I would add 3 and get X is a positive 3. And y'all remember, I said if you had a repeating answer, that's the only number you're excluding from your domain. So you're going to go from negative infinity to that number, union, from that number to positive infinity. And this will always be curvy parentheses on this one, okay? All right, so that was the example of the repeating answer, and that's the only answer you had to exclude on it. So y'all, we got one more of these. All righty. So number 7, x squared plus 15 is less than 5x. All right, so this side needs to be a 0, so I would actually subtract 5x from both sides. And I'm going to put the 5x in the middle because these are not like terms. So I would put my x squared minus my 5x plus my 15, all less than 0. All right, so let's factor. So x squared is an x and an x. The last one's positive, so both of these will be negative like the middle. So here's what I need for this one. Can y'all find me factors of 15 that'll add to equal 5? So factors of 15 that add to give us 5. All right, y'all, so let's think about that. 15 is 1 times 15. What else we got? 3 times 5. That's the only two ways to multiply and get a 15, okay? But look here. Neither one of those will give me a 5. If you add these, you get 8. You add those, you get 16. Because this last sign tells you whether they got to add or subtract to get that middle number. So since none of these will add to get 15, this one does not factor. So my answer is a no solution. And remember, no solution is a 0 with a line through it. This is what you got to put in MathLab. And y'all, when you click in the answer blank, it'll bring up that little bar with all the little tools on it. Just click the one that's got the 0 with the line in it and be done, okay? All righty, y'all. Any questions? All righty, y'all. So let me stop this share a second and get my video recordings